So we're on to question 4 of paper 1. This is a functions question. It says f of x is equal to 1 minus 2 all over x plus 4 plus x minus 8 all over x minus 2 times x plus 4, where x is an element of real numbers, x is not equal to negative 4, and x is not equal to 2. And the reason why is if x was negative 2, if x was negative 4, you would end up with a 0 underneath the line. If x was 2, you would end up with a 0 underneath the line, which would give you infinity above the line, and that's not going to work. Question A says, by forming a single fraction and simplifying, show that f of x is equal to 1, or is equal to x minus 3 all over x minus 2. So in a certain way, this is just a question which is a fractions question, and it's basically asked to simplify everything that you have up here. So you start off, you get your lowest common denominator, which is x minus 2 times x plus 4. What I always say is, okay, what did I have to do? The 1, of course, here can be put as 1 over 1. What did I have to do to this 1 to get the common denominator? I had to multiply by x minus 2 times x plus 4, so I have to do the same to the top. What did I have to do to x plus 4 to get the common denominator? Oh, I had to multiply by x minus 2, so I got to do the same to the top. What did I have to do to x minus 2 times x plus 4 to get the common denominator? Well, I didn't have to do anything, so I don't have to do anything to the top. Okay, so now we have one common denominator, x minus 2 times x plus 4. You've always got to be careful here in this part to recognize that the negative is going to affect everything above the line there. So you're going to end up with, basically it's equivalent to multiplying a minus 2 through the bracket. So you're going to get a minus 2x plus 4. You try and simplify everything down here. It simplifies down on top to x squared plus x minus 12. You're keeping an eye on your answer. You factorize the top, x minus 3 times x plus 4. Of course, the x plus 4 will divide into the x plus 4, and you're left with the answer that you want. And that was for 10 marks. So, you know, in theory, all students should be able to do that, but in practice, we know a lot of students will make a mistake with it. We continue on, of course. We can see here we have a different function. G is defined by g of x is equal to e to the power of x minus 3 all over e to the power of x minus 2, where x is an element of real numbers and x is not equal to the ln of 2. For the same reason that if you sub in ln of 2 up here for x, you're going to get 0 underneath the line. Differentiate to show that g dash x is equal to e of x all over e to the power of x all over e to the power of x minus 2 to be squared. Okay, so you start off. Here is our function. So you can say y is equal to e to the power of x minus 3 all over e to the power of x minus 2. The quotient rule, because it's a fraction, the top part is going to be named as u, the bottom part is going to be named as v. Of course, when we differentiate, so if we have got u equals e to the power of x minus 3, when we differentiate that to get du dx, we're going to just get e to the power of x. That doesn't change, and the constant disappears. Over here, when we have v is equal to e to the power of x minus 2, so dv dx is going to be e to the power of x again. So now we know that dy dx is v times du dx minus u times dv dx all over v squared. So we sub in to our formula, dy dx is going to be e to the power of x minus 2 times e to the power of x. And then we're going to have minus e to the power of x minus 3 times e of x. And again, you just got to be careful with this negative sign here. It's very important that you get this multiplication right. Underneath the line, you're going to have the original v to be squared. So e to the power of x minus 2 to be squared. We're keeping an eye on our answer. The denominator is e to the power of x minus 2 to be squared, so that's handy. When we multiply through here, when we multiply through the bracket, we're going to get e to the power of, if we say e to the power of x times e to the power of x is e to the power of x squared, which is e to the power of 2x. When we're multiplying everything out here, you can see we're going to get here at the very end, we're going to get e to the power of x times minus 3 would be minus 3x, but of course that had to be multiplied by that negative sign that was outside the bracket, so that would become a plus 3x. And we can see then, some sound effects jumping through there. We can see then what we're going to have is we're going to have the e to the power of 2x's will cancel out. And we have 2e to the power of x plus 3e to the power of x. Well, this is a minus 2e to the power of x and a plus 3. Well, if we have 3 or something and we subtract 2 of them, we're going to be left with one of them. So in this case, it's going to be left with just e to the power of x. So g dash of x, the first derivative of the function g, is going to be e to the power of x all over e to the power of x minus 2 to be squared. That's 10 marks. And, not the easiest part. You had to be good at your indices. You had to, of course, know your differentiation rules. But you were given the answer, so you'd know it if you got there. And if you hadn't got there, you might get a chance to go back and have another shot off it later on. So we're up to 20 out of 30 marks. It says find the exact values for x for which g dash of x is equal to 1. So in this case, we have our first derivative. And again, how many times do I say this is crucial to remember this, that you could have done part C without ever getting part B right. So we have e to the power of x all over e to the power of x minus 2 to be squared equals 1. I can multiply both sides by the e to the power of x minus 2 to be squared. I square out my bracket. Again, you square your first term, so you get e to the power of x to be squared, but that's e to the power of 2x. One power raised to another power, you multiply the powers together. So you square your first term, you square your last term, and then you multiply your first term times your last term, and you double, so you're going to get minus. This part here would simplify down to minus 4e to the power of x. And then once you effectively, I'll just go back here for 1 second. If I do it like this, if I say, well, 0 is equal to e to the power of 2x minus 2e to the power of x minus 2e to the power of x minus 1e to the power of x plus 4, then I can just bring the 0 to the other side. And I'm going to end up with e to the power of 2x minus 5e to the power of x plus 4. This is starting to look a bit familiar. And again, it'd be easier maybe to think about the e to the power of 2x as e to the power of x to be squared, because I could then, if I wanted, I could say, well, I could say let y equals e to the power of x, and then you're going to have y squared minus 5y plus 4 equals 0. I'm going to have y minus 4 times y minus 1 equals 0, y equals 4 or y equals 1. So in this case, then I'd be saying, well, e to the power of x equals 4 or e to the power of x equals 1. And so up here, if I've done it kind of as just knowing that this is e to the power of x to be squared. So I can say, I can just factorize it as a quadratic. So e to the power of x minus 1 times e to the power of x minus 4. Again, some students be a bit unsure about that, but it isn't that much more complicated, because again, the two constants at the end have to multiply together to give you the plus 4, and in this case, add together to give you the minus 5. So e to the power of x is equal to 1, or e to the power of x is equal to 4. I'm going to solve these. So I know the only value of x, so e to some power will give you 1. That answer must be 0. And in this case, you could think about your key rule of logs. You introduce logs. The base remains the base. What was the answer becomes the power, and what was the power becomes the answer. So now you get log 4 to the base e is equal to x. X is equal to ln of 4. We just keep a quick eye back looking at it, at the question. Yeah, it says the values, so more than 1. So in this case, we feel we have our answer, and we have it there for 10 marks. So that's the end of that question. A lot of algebra in there, differentiation. You need to know your indices rules, but a good student would have seen questions like that before, and hopefully you did well in it.